Hey folks, welcome to the stream. Hope you're having a good Sunday. Let me turn off this space heater. It's going to be loud. I was thinking a couple things change real quick, and then we'll get into it. I do too much exposition at the beginning of my streams, so I'm sorry about that. I'm going to be better about that. We're just going to jump into the code because I know that that's what people come for, and they don't want to hear me talking for 3 minutes. The other thing is I have tried to improve the resolution that I'm capturing at. I'm basically getting the same screen size, but I'm trying to export at 1080p instead of 720. So it may not look any better. I tested it last night. I didn't drop any frames, which was good. Whereas on Twitch, I think I would drop frames when I was running 1080p. But I also have my monitor is double wide 1440p. So like the scaling was a lot more natural to 720. But after today's stream, or if you drop in the comments on the live chat, let me know how it is. All right. So enough exposition. Last time we were looking at the like figuring out how to match pieces in our match 3 game. Just a reminder, this is the sort of game we're making. This was from Yo-Ho-Ho Puzzle Pirates. That I played like 2 decades ago. Okay, so there's some things in here that I was reading through the code earlier. We had done the match 5 because it's the most complicated, but there are some things that jump out to me that we can refactor, do better. So the first thing I want to do is, and this is going to be a little bit of a bottom up, but if you can see here, we got this sort of like, we need to detect the case where all 5 pieces we're trying to match do have a spot or are occupied and have the same kind, right? So, but we also need to match for 4 and for 3. And we can like hand code these again, doing basically the same stuff. But I think that the patterns that come out are going to warrant making a more general solution. So, we're gonna make some building blocks for that. Okay, so we're gonna make a function, and this one is like, I should have done this a while ago. And this is going to be a row, and a position is going to be an int. And I think I was going to do result, but honestly, we could probably return none or panic. And we'll just do row.a, and this is going to be very straightforward. And it's going to complain we're not exhaustive, so we'll do exhaustive here, and we'll just do none. So now we can think about say, this condition. So something like, starting at this position, give me 5, and and take, like, let's just focus on do all 5 kinds match, I guess. And then we can do because I think we kind of want, let's outline what we want this function to be. So we're going to take we want to get maybe a row and a position. Let's say start is an int. And then we'll do count. Is an int. And this is going to, we'll do a result here. And what I want to do is a list of pieces or nil, right? Because if they do match, if they do all match, we want to get all the pieces, and then we'll just map over them, doing this stuff, right? And we can do like result try or something like that. We'll see. Okay, so how do we do this? We have this piece at, which we can use to get the first piece. So we're going to do and here I actually want to do the mod 8 in here, and that'll save us a lot. Right? So I think that what we'll do is we'll do, if it's none, then we'll return error nil. Because if there's nothing there, then there's not, the other doesn't matter whether the other 4 pieces match, or the other n pieces match, right? We might want to do bool guard in here, because we'll need to check some input conditions, but as long as we're calling it from our own code, I'm not really particular about that. Okay, so if we have this is the first piece. And what I want to do here is let's look at the Gleam standard library, because I want to, oops, here we go. I want to think about like doing a range of some sort. So if there's anything with int. There's a list range. That's actually what we want. Okay, so let's do We may have an unnecessary iteration here, but it's fine. We're going to do list range start to start plus count. It looks like it's inclusive, so we'll do -1 there. And so we're going to maybe it's we do trifold. Yeah, so we'll say if the return value is OK accumulator, trifold will return the next value in the list. If the return value is error, trifold will stop and return that error. This is exactly what we want. So let me make this a proper pipeline. My little elixirism's coming out here. Sorry, folks. Okay, so this is accumulator and piece, or like index, right? And the accumulator we need to start with first, right? Yeah, because what we want to return is lists of pieces, not lists of slots. Okay, so then let's do we're going to do case piece at our row and our index, right? And if this is none, then we're going to turn error nil because we can never match. We don't care. If it's sum, and I think we need to do list first on this. There's a thing in, I don't know if you've seen in TypeScript, where if you do a fold over an array and you don't give it the initial accumulator, it'll just use the first item, which is what I would love to do, but we're not doing that. So I'm gonna have to, you know, the other thing, actually, let's do it like this. Okay, we're just going to do let assert because we know that we're putting one in there. There's at least one, right? So let's do some piece. And actually, we're going to, because this is the stricter condition, we're going to say if piece dot kind is previous dot kind, right? Then what we'll do is we'll say okay, and we'll put piece and then accumulator. If it's anything else, we're going to say error nil. Oh, there's no arrow. Okay, so now it's just complaining that it doesn't, it's not being used. That's fine. Okay, so now we have a generic match n pieces in the same row. Let's rename this horizontal. And because our piece at does mod 8 on there, we'll always get something within the row. We just have to have that case for type safety. Honestly, I could make it panic. Doesn't really matter. But returning none is also okay because it says you're an idiot. You gave me something that is negative. The other, and this doesn't make any sense because we're not going to do negative indexing, but we could do um, like this would be 0 and this would be 1 or -7 or something like some business like that. I don't really want to do that. Because if I give it a negative number, I am a bonehead. Okay, so I think that here we get either we either get a list of pieces, or we get an error. That's good. That encapsulates this whole condition for any number of pieces. And then we don't have to have this. I mean, this is not bad, honestly. Like, it's really clear. This is less clear, I think. But this is not generic. We'd have to repeat this for 3 and for 4. So, let's comment this out and come up with the new one. So, and actually we don't need to do it like that. We can do it here. Yeah. Okay, so we're going to do list range again. 0 to 7. Right? And then we're going to go list fold, dictionary new, and then we will say horizontal pieces match. So we'll say function, we'll call it index, horizontal pieces match, and we're going to give it the row and the start position, which is the index, and 5. Take 5. Okay, that already feels nicer. I'm sorry, this is, we're going to list map. I guess we could do it with a fold. Yeah. That'll save us one iteration. We're already iterating twice. Okay, so this is going to be accumulator, and then we'll have dictionary new, and we'll do merge, accumulator. Okay, but actually we need, okay, here's where we can do our result on wrap. And if, okay, actually the problem is, let's do another step. Yeah, I'm trying to put too much together here. We need to have something that takes we need to build this, right? And we're building this list in reverse order, so I actually want to do a result map here, list reverse. That way we will have oh shoot, I think we're gonna have the first one in there twice. So let's do start plus 1. Yeah. Because we want to fold over the rest of them. Right, because we want to make sure that this I think we can write a simple test for this as well. That should be straightforward. And that'll help me get confidence in this. Like this one is very straightforward to see. Like I hardly even need a test for this other than maybe like, did this transition get created correctly? I feel like this needs a test because it's more generic and less obvious, right? Okay. Yeah, because what I would like to do is have a function that we pass it the start position and maybe the count, and it will generate this list. Not just the start and the count, but the start, the count, and the matched pieces, and it'll, yeah. So transitions. So we'll say pieces list of piece. A start will be an int, and honestly, we don't. Let's just have it output that. I think there was a thing in here with, we don't want to like try fold. Maybe we could use, is there like a filter map? Let's see, filter map. We could do filter map. That's actually what we want to do at the higher level. Because then I'll extract the OKs, but also drop the ones that are error. Yeah, okay. Okay, so let's do, so fold over pieces, and we'll have start and an empty list as our accumulator. And then we'll have our accumulator and the piece. Okay, and then we can do, what we want to return is index plus 1, and then we want to do something with the items. We want to add one. So I'm going to say this is going to be piece dot, this is piece entity. Right, because the piece has an ID. And then we'll do P. Okay, so we're going to need the row name in here. Oops, because that's what the... Really, that's just about like dealing with the positioning, right? Okay, so we'll say row name, and then we'll say index mod 8. Okay. And then we will take pair dot second, and then we'll go dict from list. Okay, and I think there's a syntax error in this file because it is not... Yeah, here, let's just comment this out for now because we need to figure that out. Okay, now will you... Yeah, okay. Can we import Gleam pair? Thank you. This is just an easy way to say dot one. I like pipelines. What do you know? Okay. Can we do convert to pipe? Yes, thank you. Okay, so now, right, we're going to do this. Well, we're going to do filter map. Okay. So this will be, we want to do horizontal pieces match. This is a little trick, by the way. This creates an anonymous function where the underscore is filled in from the argument. You can't do it with more than one argument, as far as I know, but it is pretty sweet. So this is just going to give us all the ones that actually have a match, because we don't actually care if they don't have any matches. Like, this is just more of a way to say, where did I go here? I lost my place. Okay. The thing is, though, I actually feel like I want to do a bit more here. To save us an iteration. Because I want this to be list fold dict merge with a new one. I want this to be the end. But here we've got to do result map. Horizontal piece transitions, yeah. And we've got the row name in there. So horizontal piece transitions takes the list of pieces. So that'll be the first argument. And then we have I as the index of the starting position. And then we got row name. And this is not the greatest looking code. But hey, look at all this stuff that we removed. And you can think of this as actually, we can make this an argument, right? Is there a code action for that? Extract variable. How about that? Then we don't need this, and we don't need these two functions, which we never implemented. So what we can do here is we can go horizontal match. This is gonna be great. Horizontal matches 5. See, this is why I wanted to bother figuring out that refactoring. And now we don't have to implement it again. I do have some concerns about efficiency here, but this is our core game logic. If this is not efficient enough, then we'll have to profile. Like, I can't I can't think of anything else we would do. Okay. So let's real quick do a test for this particular thing. I think we will probably also want to test this, right? Yep. Let's split right and do a test. So we're going to do, let's do game core. Let's make a folder. Core test. Okay. So and we're going to need a bunch of stuff here. So we're going to need, we're just going to import inner as the row name. We need piece, we need slot. Actually, we don't need slot. We need row because we need to construct a row, right? We need piece entity because we're going to be asserting that. What other things do we need in here? We need to look at, we need piece exit as well. Okay. So let's do I'm unfortunately gonna have to make these public, but honestly, we're building a game. We don't actually care if they're public. And this is enough, or this is important enough to be able to test. Okay. We could also do something like this for the vertical and just have it be like, rather than the slot, give me the row and the position and I'll figure it out for you. But it wouldn't be much of a change that I'm not that concerned about changing. It would make this nicer. We could do that list range again. We might even be able to extract this. Or something like it. Yeah. All right, maybe later. Let's test. What did I really want to test? I wanted to test the horizontal pieces match. Okay. So we're gonna pick our row, and we're gonna say row. Let's make it complicated enough that we are covering at least one edge case. So let's do, and we're gonna have to import Gleam option, some and none. Yeah, I know there's supposed to be 8 arguments. So we'll do ID1 kind, and we're gonna need, like, let's just do P1. P1. Right, so we're gonna test the wraparound for 5. I think that's a good place to be. Kind P1, right? And then C is none, and D is none, E is none, and then we need FGH. Okay, so those all get different IDs, and we're testing the wraparound, right? Okay, so we're testing this function. So we're gonna say let assert okay matches is going to be horizontal pieces match. We'll do core. Hello. Okay, so we're gonna give it the row, and we're gonna have it start at 0, 1, 2, 3, 4, 5, right? And count 5. So this is gonna return us it should return us this first. So I may want to do, rather than that, rather than a match, we'll do an equals. Because the order matters here, right? Okay, here, let's just do assert okay. Let's run this test real quick. Helps if I save. Let's run it again. Okay, it's okay. So it just doesn't care about if we're used. Okay, so now we've got that. I feel let's do a few more tests here. We're gonna do match 4s and match 3s as well. So let's do a match 4. And let's do a match 3. Okay, and now let's do we want to make sure that there are cases where it doesn't match. So like we could start with let's start with like 0 and match 3, right? We could also do permutations of the 5 that do match to show that they work for 3 and 4. Let's run this test one more time. Okay, so it's passing. That's pretty good. I feel confident about that now. The big thing there that I was uncertain about was let's make sure that the list comes out in the correct order and that we don't have duplicates. It's not a big deal to have a duplicate, but I think it would mess up our logic of what position is this piece in on the board, and that would be frustrating. Okay, so let's make a test for horizontal piece transitions. Test. And we can do let's like take this result because this will be the output of that, right? And let's go I think we're going to need to import this. I did make that fun. Okay. So let's do we're going to construct this by hand, and we're going to make sure that it makes excuse me. We're testing this, right? Okay. So we'll do horizontal piece, core.horizontal piece transitions. And this is our list. And our start index was 5, right? And the row name we'll just say inner, we don't care. So here we're going to do piece entity. Let's start from here, and we're going to say piece exit transition inner. What does this take? The position, right? So we'll start at 5, and like this should be easy to 6, 7, 0, 1, right? And then we'll do 3, 4, 5, 1, 2. Okay, we're gonna have to import Gleam dictionary. We don't actually need this because what we don't care about is the contents of the transition. We just care about what position was it assigned to. So I think that this is fine. Let's run that test. Okay, so we got an error. Is it that this lerp function is not equal because everything else looks equal? 3 was in position 5, 4 was in position 6, 5 was in position 7, 1 was in position 0. Yeah, I think there's just no equality over functions. And that's the source of that problem, because otherwise it looks identical, does it not? Okay, so we're going to do let's do this, and then we're going to do let asserts on each one. And I'm going to have to import that again. Okay, and then like after this test is done, I'll feel pretty confident about this, and we can move on. What do we want in that transition definition? Just want position. Inner, and we want 5, right? So we're going to start from there. And we'll do dict get t piece entity 3, right? And we're just going to, what am I doing here? I can't even see it. Yikes. Okay, I lost the closing brace. So we're gonna do this. And we'll do the same for the others. Wish it would quit suggesting shit that gets in my way. Chris, I didn't comment because I was watching on the TV, but I enjoyed your stream yesterday. Interesting stuff with that GLTF extensions. I didn't see the entire stream, but I saw a lot of it. So thank you. All right, let's run this test. Okay, so I think I need to do T, echo T here, because if this is not gonna, and let's just do Gleam test. I don't need to. Okay, so piece entity 0. That's not what I was doing. This is 1, this is 2. Okay, that makes sense. That was just a derp. And I duplicated there. So that's correct. Okay, I can remove that echo now. All right, I wanted to do this with like a dictionary, from list, but I think checking each element is fine. Okay, so I feel pretty good about those now that we've generalized that. Excellent. So 0.18 is coming out this weekend or next week of Bevy. Okay. Let's get our bearings here. Okay, so we generalized the horizontal matches. Release candidate getting cut Monday. Nice. Well, I hope it gets in. That's pretty cool. You know what's funny? We could even turn this into list range. It's always TBD on if people feel like milestone is taken care of. Right. Well, luckily the release cycle on Bevy is pretty frequent, right? Like it's every 3 to 6 months. So if things don't make it in this one, they'll make it in the next one for sure. But I hope it does for your sake. I know that you've been doing a lot on skiing, and those extensions will be helpful to you. Okay, I'm not going to obsess over this. This is very explicit. You see the duplication here. I could do list range, but like I don't need to be a total FP nerd on this. So, okay, I see. Yeah, that's good to know. Like, I mean, this is cuckoo enough. Seriously, Sean, what? I feel confident about it now, though. So, okay, so we've got... Let's go look up at our tick function. We've got a lot of functionality here. Okay, so our tick is... Okay, we're going to advance any transitions. We'll queue vertical matches. The number of ligatures. In this, yes. Okay, so we queue vertical matches, we queue horizontal matches. I don't know that I made this queue drops function. I think that... What were we doing here? Okay, so this was just executing the drops that are available. And I don't... We may get rid of this, because what I might want to do is... And this is that thing I've struggled with in the game jam of the difference between a transitional state and a discrete state. And I may want to, now that I've thought through the problem enough, I may want to say that, well, you don't care about the discrete state. We'll apply the transitional state when the transitions end. And then if we just get the timing of the transitions correct, it'll be okay. Maybe there's some, well, not maybe, there's definitely a lot of subtlety there. This was just like, how can I conceive of if something is in a position and it's above an empty slot in the ring below, that you want it to fall, right? Because hey, I don't know if you've seen my I'm recreating this, Chris, by the way. This match 3 puzzle with 8 positions pieces can drop into. So it's like we may get rid of this, right? It may be that because we we don't want that to fall instantly. I mean, maybe it's okay to fall instantly. It might be kind of jarring though if a piece that is outside the board, right? The piece is like out here and it's falling in, and you have a limited amount of time to decide where it's going to go. If it hits this outer ring and it's like, and there's empty slots completely below it, it immediately falls like with no transition. That would be kind of weird. And I don't recall. We'll have to look at the video. I'm not going to do it on stream, but I don't recall if in the original game that if it was falling and it hit an empty slot here, if it would just keep creeping until it hit a spot where it was blocked. I don't remember if that was the case. That would be kind of interesting to code. Oh, sorry for shaking the camera there. Okay. Well, this is maybe good enough to go forth. Let's scan real quick, and then we'll go over to, I think, the board, and we'll start going. Let's look at the board state, and try to determine what the visual will be for a particular board state. And I want to get the discrete board states first, and then we'll get, you know, the effects, like the transitions. Okay. Yeah, let's scan through our core logic here. This turned out to be, like, I'm glad I did this as a separate module, but man, it turned out to be way more complicated than I originally thought. Okay. So, right, so our piece, this is basically like an entity ID would be in Bevy, and then we just have a component which is a kind on it. Okay, so this is like, did we fail or not? Do we want to reset the board? Okay, and then our next piece ID is just incrementing integer. And then we got the pieces and the patterns and then the set of transitions. Okay, fine. Our transitions is our dictionary from the entity, which is one of these two transition, because we can rotate rows. And then we got the rows. All right, maybe this is the point at which I change all of the things that say row into ring. Because it is actually a ring. Let's just do it in this file. And let's do it case sensitive. And then we'll go back and we will replace the lowercase one with ring. That wasn't so bad. Do we have any errors? Nope. Okay, good. Yeah, we've got it here. This is, let's replace that row with ring. And then the lowercase one. Oops. With ring. Hello, Sean. What is going on? Okay. And scene is going to be, yeah, let's say ring name. Ring name. Okay. That wasn't so bad. Okay. 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 So we've got the different kinds of transitions, or transitional states, really. I think that we'll probably end up tweaking what the contents of these are, but for now it's fine. Um, we'll want to pass more things to this. For example, if I think that we're going to need a row or a ring selection in the board. Right? This is the one that the players, you can see here it's like it's highlighted like that. This is the one that the players currently acting on. So you can switch between them by going up and down, and then you can rotate by left and right, or WASD, whatever your controls are. So we'll need which ring is selected. Let's just call that selected. So we will need to be able to do things like handle input, but we may not. Yeah, it could be that before we advance transitions, we queue input actions. I think the order of these maybe isn't so important, but yeah, we'll have to look at how that happens, but we're not going to worry about that today. Okay, so that's the tick, advancing the transitions. This is just updating all the tweens, and then taking action if they complete. Yeah, so on our ring rotation, if it completes, then we rotate the ring. If a piece exit completes, so if it doesn't, then we just update the tween. If it completes, then we clear it out of the ring that it's in. Straightforward. If a piece is dropping, oh, this is the one. Okay, drop and fall are a little bit not so clear. This is drop from one row to another. And I think that this was a case where we were like, we're handling that in apply drop, so we're not. Maybe it's already in. Yeah, and we're just applying, like this would be a radial offset from the origin, this tween. And when we apply the drop, we could insert this and just assume it's already there, but let it, I don't know. That might be kind of weird though, if it is, it should be really short, right? Like I would expect this drop to be like 50 milliseconds or something. Like it's not gonna be very long. But we might see the exit transition start before it finishes dropping because we're gonna check matches. We'll see. Or it might go down and then like, whatever our, like Batman zoom transition I was thinking of. We'll see. Okay. Okay, and then the piece falling. Okay, this is the falling from outside the board. And then if we've got the is tween complete, if it's true, then, or if it's false, then we just update the tween. If it's true, then we place the piece into that outer ring at the position that it's in, and then we update all that. So, and we delete, yeah, we're deleting the transition from that. Okay. Rotate ring, these are straightforward. That was one of the first things I wrote. Okay. We could do this with a like list all over a range. That'd be interesting. I don't need to change it though. Okay. Okay, right, and this is just all the rings. Match the patterns. Apply the drops. Execute the drops. We're not actually. Where are we calling this from? Oh, it's just public, so it's not complaining about being unused. I think in our tick we'll need to check that condition. And then we'll generate, we'll inject the exits, and then we'll generate new patterns. Okay. All right. And that was executing the drops. Placing a piece is just put it in that spot. Clearing a piece is removing it. It's fine. Okay, and then we are doing our vertical matches. We looked at this earlier. And we can tweak that. I kind of want to put this up at the top of the file. Let's do that. Because we'll be wanting to tweak our values. Right, and this is our constant. All right, and so here's the thing. I wanted to make this is just easy in cubic, but I wanted to make this actually be, because it's going to be a scaling thing, I wanted to use the ease in back, but I was adding that to Tiramisu because it didn't have that transition. You'll remember that one from Fable, Chris. Of course, we had those all defined as like a list of Bezier segments. Rather than, you know, the easier, like, just compute the t value. But we're not building an editor here, so we don't care about that. We can just use the regular function. All right. I feel good about the core for right now. Let's go look at the board. At some point, you can see, like, my project browser is all a mess here. I haven't committed anything. So we'll commit today, and I'll push. So yeah, well, neither place is built. It very true. Okay, I know I'm not personally capable of this, even just from a issue of time. But I have thought about, what if we like resurrected something like Fable in open source? I'm sure people have tried to do that sort of thing before. But Fable was a good product, and I'm kind of sad I'm no longer working on it. Such is life. Okay, so we're already rendering the rings. Let's get our server running again here. And yep, let's refresh. Okay, so we've got our rotating lights. We've got some rings. They're kind of dark. I'm not sure about the look of those yet, but we can fix those later. What I want to start doing now is we need this to take not just the, wait, what is the game state? It's just the enum? Yeah. We need this to take the board as well. Yeah, it needs a core use case. There's plenty of things like M&M. Yeah. Um, yeah, I was just thinking like it would be nice to have something sort of like what graphite does, where it just uses local state. There's no server. It would make it harder to render um, video if like that was the target. But we did some fun stuff with Fable. Okay, let's find where this is called. I think we're doing yeah. So the model, right? We don't have a board in here. So we may need to implement that. It's going to complain because we haven't filled it out here. So we're going to make a board. And let's split this right so I can see it. So our board is going to start with next piece ID. Here, will the language server do this? Fill labels. Thank you. So next piece ID will start with 0. The state is plain. Pieces, we're going to do, let's make some functions here. And honestly, at some point, we'll just make this into like, give me a new board. The rings, let's return rings. And we'll just do rings, inner, new ring. I always say empty ring. It's fine. New ring. Outer, new ring. I don't know if I'm going to need to make this public or not. We'll find out. Let's just make it public. Ring. And this is A, none, B, none, and so forth. C, none, D, none. This is where, like, the default trait would be really great. We could just, have it derived. Okay, so we're going to say pieces is new rings, core dot. And we'll do patterns for now. It's going to be empty. We don't care about that. We're going to figure out that later. Selected, we'll start with the inner. Yep. And transitions is going to be empty. Okay, and let's actually make this new board. Let's just extract that. That's fine. Core.new board. Okay. All right. So and we're going to pass the model.board and the context delta time. Yep. Okay, so we've got that. We may want to do this later. Okay, so now we've got a board in our state. And this function, right, is going to take the core board state. So, okay, so now we got that passed in. We're not using it, but we can do something like, yeah, it'll get over that expected one where we got to. We're going to do like that, right? And here's where we're going to figure out okay, and this is going to be a list of scene node ID. I want to say I made a type for that. The problem is I have this module called scene, and there's this, you know, tiramisu module called scene. Yeah, you could use Velo. That's very true. I haven't checked in on the state of Velo for a long time, but it looked like pretty awesome stuff. I mean, freaking GPU 2D rendering, like on GPU, not like just sending the primitives to the GPU and letting it render the polygons is pretty sweet. Okay, so you know, here we give this, put that away for a second. We're rendering these rings. There's some bits here where I feel like this one's too far out. Like you compare it to this and it's pretty small. Like they're still spaced evenly, but like I feel like I could make the radius of this smaller. I don't know that I want to right now, because we still haven't, you know, that feels like a visual tweak we can do later. I'm also like doing this scale uniform across all of them, which is kind of annoying, when I should really just like update the radii and the tube width. Let's see if we can do that. So we make this 1.5.15, right? And that would make this one 225. I'm mostly just trying to figure out, yeah, that's 3. Get rid of that. See if that completely blew up our visual. Probably, knowing how good I am at this stuff. We're not even rendering. Oh, what happened? What did I break? There. How did changing that completely break my visual? Oh my gosh. Well, let's back that out, for Pete's sake. Oh, is it just this? I think it was just that. Okay. Yeah, there we go. Okay. Like, okay, 1.5. This is 0.15. We can actually probably make those bigger, but okay, 2.25 and 3. And then get rid of the scaling. Okay, still the same. Okay. So okay, we're only worried about pieces here. And at some point we're going to have to just like put some pieces in there for testing's sake, which is fine. I think we can do that. Let's see, we got about a little bit more than half an hour left of my plan. So we've got the inner ring. And I think that we want to maybe we have a function that just gives you the pieces and their positions. We also have this function is public. So we could just loop over it. Loop over from 0 to 7. Yeah, let's look at the filter map is result. Like we'd have to turn those options into results. But I think what I want here is, what is the, okay, that's just the color. Where am I calling this from? Nowhere yet. Let me move this module into here. Because I think what I want to do is say like, we're gonna have to do some trigonometry for sure. And maybe we just plan that out right now. So I would say that like we can either make 0 be the top or to be the right. That would be the simplest because this is X and this is Y. And our Z is, layering because we're in an orthographic projection. So we could say, there's 8. So we go 0 to 7 times pi over 4, right? And then we'll have a distance from the origin on that angle. So we're probably going to have to do some more like polar conversion stuff. Let's just make angle of the thing is we could say the transform would be let's just make a function that does the transform. And we're going to give it a row name. Core.row name. Because that'll give us the distance. Dot transform. And that'll be the base transform, and then if we apply transitions later, we can tweak that transform. And then we're going to do position, which is going to be an int. Okay. So let's do, we're basically going to say we want to rotate around the z-axis. So let's do transform dot at and our x is going to be 1, right? So the thing is we're going to actually do let's let's do let x is case row name. Why are you not getting that? Did I not make that public, that type? What is going on there? Did I mess that up? No, it's just not highlighting correctly. Oh, rename. Trolling myself in the same stream. Okay, rename. And let's rename that rename. Okay. Now add the patterns. Okay, so inner, we're going to be 1.5. And this is something that I think I'll want to extract out as constants. Middle is 225 and outer is 0. Okay, so this is going to be x, 0, and then the z, we need to think about where the rings are. So they're at 100. We want to be closer, so it needs to be less than that. I don't remember what other ones I used. Like in the lights, we picked a 95. So the pieces, we want them to be lit by the same lights. I think like if the rings are at 100, and maybe we do another module here which has layer constants in it. Let's do these at 90. Okay, if this is a torus and the tube is 0.15, so like we need to be above that. Let's pick 99. Okay, and then we're going to do transform.rotate z. No, rotate z. And then we'll say maths.pi divided by 4 times int to float position. And we've got the times 4 divided by 4. Okay, we need to import that. Okay, so now I can go through each of these. I need to qualify that. And then we'll map that to we want a flat map. The way I'm thinking about this is we want to focus on iterating over the fields there. So we'll do list range again, 0 to 7, right? And excuse me. Let's do filter map. And this is going to be we're going to get the piece at this takes what, the ring, yeah, the ring and our index. And if we have none, then we're going to return error nil, right? Okay, if we have some and there's a piece there, this is where we're going to do our construction of a node. So we'll do something similar to like this. And I think for now we will probably create the geometry once if we can. Yeah. And we're gonna just pick something. I think I'll do like a tetrahedron. Yeah. And what does that take? Okay, so the radius, yeah. We're gonna pick 0.5, I think. Yeah, assert okay. Or 0.25, and then it was what, detail 0. Yeah, we don't need any, like, let's do 1 triangle per face. I don't really need more than that right now. Okay, so then we'll do something like this, right? Let's just copy this because I think I kind of want them to be as shiny as the others. But we're going to import, rather than this, we're going to import the function we made earlier. Color. Not kind. That's fine. Hope y'all are following along okay. Okay. So now we need the transform for this thing. And then we'll make the mesh. We'll say piece transform. Right. Okay, so now we're on the right. So I've got an error there. So this is let's rename that. So here we'll do rename and I. Okay, and now finally we'll do scene.mesh. We should really do instanced mesh, but I don't. The problem is we've got different colors. They're the same geometry, but they're different materials because they have a different color. I kind of wish that this API would give me a better way to do that. Like, you can have an instance mesh, but like transform these properties. Right now, it's just the transform, just the positioning. So I think we just need to be okay with this for now, and then we'll improve upon it later. And this needs to be wrapped in okay because we do want to return it. Okay, so what does mesh take? We did an example down here. Okay, so we need an ID. let's just copy this. Okay, the ID is going to be piece. Or it's going to be board piece. What did we do here? Yeah. And like, this is why we're going to have some conflicts here. Okay. Yeah, and then we're going to fix this. So the geometry is going to be the piece geo, and then we'll have material, and there's no physics. Okay, piece material. Okay, so it just doesn't know what that is. How? Oh, it helps if I do this. Error. And then it doesn't know. Okay, so I just don't have option sum in there. Okay. Cool. Yeah, are there even if it weren't instantly? Probably not. Like, honestly, you know, like you would have at most, like this is theoretical. With the game mechanics, no, this would never happen. But like you would have at most 24 of any single piece. Maybe 25 because you have one falling in. So like it's not that many. I'm not that concerned. Okay, the only thing that I'm concerned about with this transform is what's the anchor of the rotation? Is it rotating from the center of the geometry, or is it rotating around a fixed point? I don't know. I guess we'll find out, and I think that we'll probably get okay, so I actually want to do here, we're just gonna, in our new board, we're just gonna fill in some pieces. Where's our new board function? Here it is. We're gonna make this up. We'll do some more like interesting stuff later in terms of generating the patterns and so forth, but I'm just gonna put this is going to be dumb, but I just want to get some data in there. We will back this out later for sure. And let's do 1, 2, 3. We may need a function that's like, hey, give me, you know, a random number from 0 to 4 and then pick a kind for that because we enumerate that. Okay, so we've got some pieces on there. They look like shit. They look really bad. But hey, so this is interesting. They're in position 1. So I think our transform is incorrect. But note that they're lined up correctly with the rings. So at least we got that part right. They're not getting any glistening, shiny stuff, even though we made that, use that same material. Different colors though. Okay, let's look at the transform. So this is correct. Oh wait, okay, so yeah. So I think that what we need is not this rotation. This is, yeah, what we need to do is compute the X and the Y using our polar transformation. Okay, so I'm going to say let angle, and we're going to say this is distance, not X, because we're going to compute X and Y. Yeah, that's the part that I got wrong. Okay, so we're going to say let X equal distance times maths dot cosine of angle, and Y is distance times maths sine of angle. And then we'll put Y in here. Okay, so still not correct. Let's throw in a debug point, I think. Why is it 1/4? So I think that if it were 0, it'd be vertical, which is okay. But that's opposite, like that's off by 90 degrees of what I thought. I don't know that this is going to make a difference because I think that it's just left to right. Yeah, it doesn't make a difference. Okay. Do I have a handedness problem here? I'm not sure. Are they inside the rings and the rings are blocking the light? Possible. Let's move them up a bit. That's a good question. No. Oh, you see a little bit of glow there. The light in general is so low here. Like I could bump up the ambient. Like let's bump up the ambient intensity to 0.8. The problem is it tends to wash it out, and I like want that specular highlight. So let's put that back. We bump up the directional. I don't know if that's going to make any difference. Eesh. Here. Yeah, it doesn't like, I don't have my scaling correct there. It's fine with vertical shrinking to a point, but here, did I make that key combo? No, I did not. I only did that on my work machine. So like, I mean, I don't know that the numbers actually make that much difference past 2. Like the docs kind of indicate that 2 is supposed to be really bright. And it's a little bit hard to see because of the flash of the reload. Unfortunately, the hot reload is not really sophisticated yet. So you get the blinkiness. I don't like that much, but so this directional light being at 0 will be behind the camera because we've got our near. We look at the camera, and I need to redo all this, but we've got the near as 0.1 and the far is 1,000, and so these are at 100. The rings are at 100. Yeah, see, I want to kind of get them below the lights, and I honestly could maybe make these point lights be higher. Let's get so like higher off the plane. Let's get them at 90. I don't know if that makes any difference. Like the main thing I wanted was that kind of glistening effect where you can see that the thing is not just flat. I mean, we're doing something similar here for the X and the Y for that light moving around. The other thing that we could do here is we're not inputting the time into this. Like, I think that we'll probably want something where these spin or they like have a little effect. Yeah. So that you can see that, hey, they exist and they're not just like flat squares. I don't honestly know, I think, enough about lighting right now to know what to do here to make this like actually work out the way I would like. Because in general, the whole thing is so dark. Now the background, like, I made that to be pretty dark. It's supposed to be dark because it's not supposed to be the main thing you're looking at. Yeah, like we're passing in the time here. Let's pass that into the board too. And then we can pass that down into here. And that'll give us something to do some like rotation on. Yeah, let's just put it down in that piece transform. And then they'll be consistent, right? And we want to rotate Z. Let's see, we could rotate Y. Okay, model.time. Well, that's fun. Look at that. They're rotating. That's not what I wanted. Okay, Chris, you asked what lights are in the scene right now. Maybe I answered that already, but we have, we have an ambient. And this here, like, we can bump this up to 1.0, and then it's really bright, but things look washed out. Okay, so tetrahedron is a pyramid. This is not exactly what I want, possibly. But yeah, you can see the pieces rotating there. Yep, I do have an ambient. It's the intensity set to 1. The color is white. This is just the ID, by the way. For the it's just the index of the light object. And they do that for scene diffing. So like we just have this index type. The scale of the value linear there, not clear to me. So they say, yeah, this is a bit where, I mean, we can try brighter. Maybe I just need to do that. Like, let's go crazy. Let's go with 5. Whoa. Note the background doesn't change that much. That's actually kind of good. We're gonna have to pick a different color for that piece, and also we're not really casting any shadows there, so the contrast between the pieces and the rings is gonna be a problem. Let's bump that back down to 3. 3 is pretty good for visibility. Okay, so the directional. It can cast shadows. So I think that there might be a case where what we want for the directional is not for it to be straight on, but to be off to the side, so we get shadows. So let's do the X. Let's do it at 1.0. The Y at, let's do it from the top right, and then we'll do 0. Okay, that's interesting. You notice a subtle difference there? We could also just remove our directional light and see. Yeah, I would expect them to be like, yeah, I don't know that there's really shadows being cast there, but there's a little bit of a contrast difference, which is intriguing on this directional light. The values are there are strange. Like I think that we need to look at the 3JS docs, because I think that there's something here that I'm missing. Okay, so right, they make an ambient light. The other thing that we can do here too is look at one of the tiramisu examples. Oh, it's not in here. Here we go. Nope, I was trying to maximize you. Thanks. Okay, so we could look at the examples, and like for example, the one that I worked on when I was adding displacement maps was this materials and lights, and we can look at what they do in here. I think that's probably a good way to go. Okay, so they've got a camera. The lights are, they've got an ambient light with intensity of 0.3. They've got directional, the intensity of 2. We should just run that example in a second. Excuse me. They've got point lights with intensity of 1. Oh, there's a hemisphere light. Interesting. What does that do? Outdoor ambient lighting. Hemisphere simulate outdoor ambient light by using different colors for sky and ground. Objects facing upward receive the sky color, downward receive the ground color. Okay, I don't know that that's relevant for us because we're just not in a scene where you can walk around. Yeah. Interesting. But like, yeah, let's kill our because I have tiramisu up here because I was working on the easings. But if we do examples 3, I need to do run luster dev start. Okay. Okay, so this is the example. And you see it's actually pretty bright even with the, of course we've got, you know, the hemisphere light. And you can see, hey Chris, you can see here the displacement map I added to the wood. Gives it that bumpy texture. Pretty sweet. But like, look at how bright that floor is. Yeah, this looks really reasonable, and I think it's just like user error. Oh yeah, the displacement is cool. Like, it doesn't look real great on a sphere because you're wrapping this wood around, and so you get those at the edges of it. You get those creases at the edges of the texture. But if you look carefully, you can see that it does map to the coloration of the wood, which is pretty sweet. Yeah, don't slip. No kidding. Looks wet. Wet as hell. And like they've got in the scene there, you can see they've got that point light moving around, and it casts a glow, casts a reflection on there. Um, Not really casting shadows from the spheres. Like they're just not. But the lighting in this is good. So I'm wondering uh, what is different enough in here. Like I can directly compare this example, right, to what we did. And I want to say earlier in this project, I just like copied a bunch of things. I was like, I don't know what I'm doing, so let's copy these lights. Okay, so it's actually the directional light that is moving. The point light is not. The intensity on that is really high too. So, and I was using the point lights to get that that like little animation effect. But maybe what I need to do is move the directional light. And the other thing is, okay, so their ambient light is at 0.3. And it's also this kind of gray color. So I wonder, dark gray actually. It could just also be that this scene is so minimal. Like, and we're not rotating the camera around at all, right? Like, we're not going to get what we want. Before we go, I want to do one more thing, and that is I want to change the geometry of those pieces. We're going to have to do more with that. We may even have to go to Blender, but for now, we could do an icosahedron. Let's see what the parameters are for that. Okay, so that's, yeah. Let's switch that to an icosahedron, and we'll see. The thing is, it's going to be 20-sided, so it's going to look almost like a sphere. Oh boy. Where are we at? Let's see what that does, just for now. Oh, that's kind of cool. They look like. Oh, note that like there's a little bit of a flash. Yeah, it's not so ideal. As they rotate. But as they rotate to face that directional light, they're reflecting it pretty intensely for a brief moment. Let's poke at that for just another minute. The other thing that we could do is have it rotate in all three directions at different scales. And then we'll get a very funky kind of irregular rotation. Thanks for coming, Chris, and thanks for your ideas. Um, yeah, we can play with that. And this is not going to be ideal. I think it's going to be better to have the colors change, but also um, back. It's a little bit more contrast because I think those are light blue on there. The colors, but also the geometries change. So like we should pick a geometry based on the piece kind, not just a color. Yep. I think let's do one last tweak and then we'll call it for the day. Um, it's good to see. It's good to see our board mapping um, to the geometry. Like that is really satisfying to me. Interesting. Look at the change. When we change the roughness, we get less of a flash, but we still get the highlights as they rotate around. And this is, I think, a little bit of me just not understanding the standard material well enough. That looks pretty damn cool, actually. Let's do a screen grab of that. We'll do the last bit for today, and see, quick time. We're gonna do new screen recording. Let me just get this, and then we will call it for today. We don't need a timer. That's pretty good. All right. Cool, and I'll upload that with my social media posts after. So, good stuff. And then like I think next time we'll focus on getting distinctive pieces, and getting the gameplay. So like connecting the controls to the state transitions of the game, which will be really great. We can figure out how to render patterns. We can probably put those as like other circles that are down below this, and that'll be great. So thanks for hanging out, and see you next time.